Hello, I'm Mrs. J, and for these two sections, it's compounding interest or compounding an account. We will use these two formulas. This one is if it's a compounding amount, quarterly, monthly, daily, yearly. And this is the formula you use. A is the final amount or the amount at the end. P is the starting amount or the deposit. N is the number of times it's compounded in a year. T is your number of years, and R is the rate as a decimal. Now, if it says compounded continuously, which the second set of problems we use, you use this formula. The variables stand for the same thing, and E is a function in your calculator. It's right where your ln button is, e to the x. So it's not a variable you're plugging into. Okay, let's try some. Where'd it go? There we go. Okay. So Jane needs $4,818 for a future project. She can invest $3,000 now at an annual rate of 6% compounded monthly. So compounding amount, that's what tells you it's this one. Assume that no withdrawals are made. How long will it take her to save enough money for her project? So we know we're using this formula. Now we plug in. Well, she needs $4,818. So at the end, the final amount needs to be $4,818. She's starting with $3,000. She has $3,000 to put into an account. R is the interest rate, 6%, written as a decimal. Compounding monthly would be 12. So then 12, and time is what we're looking for. So then we need to solve it. Well, first thing we need to do is get this by itself. So we're going to divide by the 3,000. Oh, that does divide by 3. Now, if it doesn't divide, if it's a repeating decimal, you want to keep all your decimal places until the end, but I think we can divide this one. Yeah. 1.606. It's not repeating, it's a terminating decimal. Okay, now we want to be able to bring this variable down in front. Well, remember, to do that, we take the natural log of both sides. Because if we take the natural log, we can bring the 12t down. There we go. Now we're trying to get t by itself, so we can divide by the 12 and the natural log. If you want, you could calculate this. I think it comes out nice. 1 plus 0.06 divided by 12. Yeah, 1.005. But again, if it's a long repeating decimal, you need the whole thing, so then you would leave it like this. So t equals, and then we just plug this into our calculator and round to the nearest hundredth. So natural log 1.606 divided by, and then put your denominator in parentheses, 12 natural log 1.005 equals. 7.9. It said the hundredths, so that 1 is going to round up to a 2. 7.92 years. Let's try another one. Okay, this one I looked, it's compounded monthly again. Oh, yeah, it's a different one. No, it's the same one. Semi-annually. So monthly is 12. Semi-annually is 2. Quarterly is one that's used a lot. It's 4. And they might use daily. And usually it's 365. If it's something different, they will tell you. Okay, so suppose that 4,000 is placed in a savings account. So that means we're starting with 4,000. At an annual rate of 5.6%, 1 plus 0.056. Compounded semi-annually is 2 times in a year. With no withdrawals are made, how long will it take to get $6,052? And we're looking for time. So first thing, divide by the 4,000. That again, I think we'll divide. 52 divided by 4,000. Yeah. 1.513. And let's try this one. 1 plus 0.056 divided by 2. So if we calculate in the parentheses, it's 1.028 to the 2t. So this is that. Now to get the exponent down, we'll take the natural log of both sides. So we have the natural log of 1.513 equal to, bringing the 2t down, the natural log of 1.028. Solving for t, we divide by the 2 and the natural log of 1.028. Plugging that into our calculator. Natural log 1.513 divided by, and then put this in parentheses, 2 natural log 1.028 equals, rounding to the hundredth, the 9 will round up, so it's 7.50. So 7.5 years. The other ones, oops, wrong, here it is. Finding the rate of time, this one, uses exponential. But the steps are the same. A lot of people remember this by Pert shampoo. So it says, let me open it up so you could see the whole thing. Oh, just there. Suppose that 1,800 is invested at an interest rate of 2.5% compounded continuously. How many years will the initial investment be doubled? How long will it take before it doubles? Do not round any intermediate computations, round to the nearest hundredth. Okay, so we want to know how long it takes to double our money. We're starting with 1,800. We know our interest rate, written as a decimal, is 0.025, and we're looking for time. To double, if we take 1,800 and double it, we want 3,600 at the end. Sorry. We want 3,600 at the end. So then when we solve it, we will divide by the 1,800. Let me get my other pen. Because we want to get e by itself. You don't want to take the natural log of both sides till the e is by itself. This gives us 2 equal to e 0.025t. Now that it's by itself, we can take the natural log of both sides. So we have the natural log of 2 equals 0.025t, and divide by your decimal. And then just plug that into your calculator. The natural log of 2 divided by 0.025. 27, it says round to the nearest hundredth, 27.73. Try one more. I know it's already compounded continuously because that's what this section is. Okay, so suppose that the number of bacteria in a certain population increases according to a continuous exponential growth. That's what's telling you e. A sample of 1,500 bacteria selected from this population, so we're taking 1,500. Reached the size of 1829. So 1,500 went to 1829. In 4 hours. Find the hourly growth rate. Now, since it's compounded continuously, we could let h be hours. Will they let us do that on here? Yeah, time can be hours. When you are talking about the banking values, T is always in years. But when you're talking about growth and decay, you can change it to hours, minutes, whatever you need. And so T is in hours. It says, find the hourly growth rate. So we're looking for R. And T was 4 hours. Right here. So to get E by itself, the first thing we do is get rid of the number in front by dividing it. I don't know if that'll divide nice. I'm just going to keep the whole thing. And then I'm going to take the natural log of both sides to get rid of this E. Lastly, to get rid of the 4, just divide it. And then plug into your calculator. Move this over. And we're rounding to the 100th. So we have natural log 1829 divided by 1500. Close the parenthesis and then divide by 4. So R is rounding to the, write your answer as a percent. Do not round. Okay, so it's 0.049576065. Now we're writing it as a percent. So first we make it a percent, which puts the decimal here. And then we want to round to the 100th, which would be here. So we have 4.9, and the 7 makes this a 6%. See if we can find one more of these. That's just an interest. Interest is easy. Oh, come on. Okay. The mass of a radioactive substance follows a continuous exponential decay. That exponential is telling you PERT. A equals P e to the RT. The mass of the with a decay rate parameter of 5.7%. That's your R. 0.057. Find the half-life of this substance. That is the time it takes for 1/2 of the original amount of the sample to decay. So we're looking for time. Now we want it to be half. They didn't give us anything else. We'll pick something. If this is 10, this needs to be half of it, 5. If this is 100, this needs to be half of it, 50. If this is 2, this needs to be half of it, because they want it to end up to be half. So whatever you pick here, this has to be half. So you could put 1 and 0.5. So I use 10, and half would be 5. But it doesn't matter what values you use as long as whatever this is half. And then we got to get our E by itself. Then we need to get rid of E. Those cancel and leave the natural log 0.5 equal to 0.057t. And then we divide by it. And plug into our calculator. Natural log 0.5 divided by 0.057. Okay, now notice we're getting a negative value. The reason we're getting a negative value, because this is a decay, your R needs to be negative. So this negative is because I didn't make my R negative. So when you have a growth, this is positive, but when you have a decay, it needs to be negative. So these should be negative. That way then, when you get this negative, it'll become a positive because of this. So then it's 12.16. So be careful, because it's a decay, you need to make this negative. I was thinking we were looking for R, and that would come out at the bottom, but So a growth is positive rate, a decay is negative. Try one more. Okay, this one's doubling, so your growth is positive because it's a growth. And want to know how long it takes to double. Again, they're not giving you values, so you could put 1 here and double would be 2. That way 2 equals e to the 0.011t. You can just start with the natural log because this has to double. Then just take the natural log of both sides. And it is positive because it's increasing. And then divide by the 0.011. So natural log of 2 divided by 0.011. And again, we were looking for years.